My name's Ben. I'm here today from the Young Rail Professionals. But actually, I think, in a minute I'm going to state my case on the railway and why I think it's really a kind of a career option that people should think about. And I really would like you guys to hopefully go away today understanding a bit clearer about all the fantastic, innovative things that are going on in rail today. But actually, this is great. Getting around together, engineers, thinking about what they want to do. If I was at university and I could have come to an event like this and be able to see all the things that I could get involved in, it would be fantastic. So I've really enjoyed the first two presentations, and hopefully by the end of today you'll have a much clearer idea. Clearly you've already picked engineering, so that's an awesome first start, but actually what comes next, and that's really, really good. So my talk's entitled Welcome to the Railvolution. So I guess, who am I? So my name's Ben. I'm sat in one of the brand new Crossrail trains there that will be bound for London. The first one's in London, testing on the route at the moment. That project is going to increase the carrying capacity of London's rail network by 10% when it opens, which I'm sure you'll appreciate is a massive, massive improvement in a city that is growing and becoming more and more congested every single day. I guess contrary to the presentation we've just heard, I'm more on the design end, so actually having the opportunity to get and physically touch and see a train once in a while is actually quite nice. And the reason I got that opportunity is because I'm quite tall. So they go, Ben, you're quite tall. Can you come and sit in the driver's seat and make sure you've got enough leg room and can reach the buttons and things? So of course I jump at that opportunity. It's quite good. I studied at the University of Salford, so not far down the road at all. It's really nice to be back, so thank you to the team for inviting me today. I studied mechanical engineering, did a master's, graduated in 2013, so I'm kind of 3 and a bit years into my career to give you guys a bit of context. And when I kind of left university, I was looking at what I wanted to do. Did I know exactly what I wanted to do? No. Did I know kind of what I wanted to do? Well, I knew I was interested in products, so I certainly wanted to go and work for a company that designed and built things that ideally ordinary people get to use. That really motivated me, being able to kind of impact society and make a difference to real people. I was scrolling through the job sites and found Bombardier, and we always joke that it's the biggest engineering company that no one's ever heard of, because actually Bombardier, the world's 3rd largest manufacturer of civil aircraft, behind 2 companies that you may have heard of, and the world's largest manufacturer of trains by volume. We build more trains every year than everybody else. And I guess to quantify that, a Bombardier plane takes off or lands once every 3 minutes worldwide, and our train products, just our underground and subway products alone, carry the equivalent of the entire population of the Earth, so about 7 billion people every year, and that's not even including high-speed trains and all that kind of thing, and trams. Of course, you've got a Bombardier tram network here in Metrolink. But I'm here today in my capacity at YRP. So YRP is Young Rail Professionals. What is that? Well, actually, it's a group of young people that all work in rail, all different parts of rail, from trains to signalling to infrastructure, who actually, most of us have stumbled into rail. I didn't target rail directly. Most people don't. Most people don't think about it. And actually, having got into rail, understood actually it's a growth market. There's not enough people, so the opportunities are fantastic. The projects are big and exciting and innovative. We really want to come back out and speak to people, be it at school age, university age, or people looking for a career change, to, I guess, just educate you a little bit, let you see what is actually happening out there in the world of rail. We claim that's our primary purpose. We go for beers sometimes as well. That's a big part of it. But it's about networking and building that development around you and learning from other people, which is so important. And as we've said earlier, that's the benefit of some of these organisations. So YRP primarily, we say it's about promoting, developing and inspiring both people already in rail, but also people who are looking for potential careers. And really, as I say, it's massive. The huge variation in rail as to what's going on right now is massive, and whether you're more interested in software and control all the way through to engineering structures, there is something for everybody. These pictures were taken from National Rail Week, which was organised by the YRP. Over 100 events up and down the country aimed at promoting rail. So on to the main bulk of the talk. Welcome to the Railvolution. I'm a fan of a pun. I was particularly a fan of the previous presentation. I thought that was a brilliant title. What I'm going to talk to you through is I'm going to talk you through 6 kind of innovative or revolutionary things that are happening in rail right now. Just give you a feel for actually rail is an innovative industry with lots of things going on. Before I joined it, I had no idea, and I imagine many people sat in this room see the aging. I mean, the rail infrastructure in the northwest isn't great. There is investment coming. I studied here, the train's quite frankly awful. You get rained on when you're in the train. I don't get that. So I want to really show you guys that actually there is great things going on around the rest of the country. So the first one I'm going to kick off with is Railvolution number 1, wireless train. So I'm sure there'll be fans of Formula 1 in here. I'm sure you'll have heard of KERS, which is the energy recovery system that they're using in F1 for a couple of years now. Clearly that's a very innovative, forward-thinking, fast-paced, sexy technology that's now steadily making its way into road cars, from the LaFerrari and the McLaren P1 and the Porsche 918, all the way through down to actually the electric cars that have to recycle the brake energy in order to extend the battery life. Well, actually, that regenerative technology has been used in rail for years. Electric trains for a long, long time have been taking their braking energy, using their motor as a brake to create as a generator and pumping that back to the grid. And actually that means that rail, as you can see here, is one of the most green and environmental forms of travel in terms of grams of CO2 per passenger kilometre. So if you're interested in making an impact environmentally, but you're still interested in transportation and moving people around, which is seen actually as a negative environmental impact, the railway is a great place to come and work, to take these technologies that have been developed and improve them. And that's not to say that the improvements that F1 have made in that technology can't be brought back to rail to further improve it for our benefit. So how do you take this to the next level? Well, everybody from Tesla all the way down the chain, looking at batteries and transportation. Motor technology is very well developed, it's very advanced, whereas battery technology, as I'm sure we all know, isn't. So in terms of trying to take the next step, which is battery-powered trains, we're seeing the exact same challenges in terms of the weight of the batteries, the chemistry that you decide to use, actually the environmental problems, so allowing those batteries to work effectively over the range of temperatures that you'll see in this country, which is quite a large range within the UK. So this was a project that was done across the industry. Network Rail were involved, the train operator Abellio were involved, my company Bombardier were involved. We designed and built these trains originally, and we actually outfitted them with batteries. And we did a series of tests in passenger service, so passengers could get on this train and use it. It could still hit the top speed of 110 miles an hour under battery power, and it could go up to 80 miles without needing a recharge. Now, why is this important for the rail industry? Now, of course, in a lot of areas you've got the overhead catenary, the overhead power lines, that's great, but actually installing and maintaining and upgrading that equipment is really, really expensive. And what does that impact on ultimately? Well, it ultimately impacts on the fare that the passenger pays. If you factor into that the sense that some lines, it will never be economical to fit overhead catenary because there's not enough traffic, rail traffic on it, and therefore you can't justify the investment. Actually then have an environmental factor. So what, do we run diesel trains forever on branch lines? Do you shut the branch line? How do you build your way around that? So, you know, we can use technology and push rail travel forward in order to be more environmental, but actually ultimately drive the cost down for the passenger, which is really, really key. So that's the first one. Railvolution 2, command line. So clearly trains are getting smarter. And we need to, one of the major issues really is around speed. So how can we get trains moving faster? And capacity, how can we get more trains on the network at any given moment in time? So one of the big technologies that's coming through now is something called ERTMS. It's an acronym, engineering's full of them, and you'll be sick of them by the time you're in the first year of your career, I guarantee it. ERTMS is the European Rail Traffic Management System. Currently in Europe, there's 20 different signalling systems. None of them talk to each other. So certainly if you're trying to run a train from the UK through the Channel Tunnel onto the continent, or you're trying to run from Germany into France, you know, these trains are having to operate 2-3 different discrete signalling systems. They're complex, they're heavy, you've got to assure the safety of them. So we're trying to move to a unified system. So that's great, but on our little island, fine, we don't interoperate a huge much. What are the benefits for us? Well, ERTMS level 2 allows for in-cab signalling. So instead of having kind of the traffic light style signals at the trackside, you can actually fit them within the cab so he can see it within his cab. What that means is he doesn't need to slow down before a bend to wait to go around the corner to see what the light says. He knows what speed he's allowed to do at any moment in time in his cab, so he doesn't need to slow down as much if he can't see a signal, for example. And by the time you progress to ERTMS level 3, it allows you to transition from what we call a fixed block signalling system to a moving block signalling system. So what does that mean? Well, a moving block signalling system is what you do when you drive. So every car owner, you're operating your own moving block signalling system in your head. You're maintaining essentially an invisible barrier around you between you and the car in front. And as you speed up, you'll make that gap slightly bigger, and as you slow down, you'll make that gap slightly smaller. But you're constantly moving, dependent on your speed, with a box of a certain size around you. A fixed block system, which is what most of the railway currently uses, is the equivalent of you pulling onto your street, seeing that there's somebody else ahead of you on the same street. You have to wait for him to leave the street so that you can then go on the street, because then it's safe, you've got the street to yourself. And that's how the railway currently works. It's chunked up into lots of discrete little bits, and you have to wait for the person to exit the one in front of you before you can enter it. Clearly, that is slowing trains down, and it means that the capacity isn't where it needs to be. So ERTMS allows capacity to increase by double, and it additionally allows for increased speeds, theoretically up to 500 kilometers per hour. That's Railvolution number 2. As we go through these, I'm trying to demonstrate the fact that we need a whole range of skill sets, from traditional mechanical engineers to structural engineers to software and control. Railvolution 3, happy passengers. People using their phones all the time. You look at rail travel, people in stations, people on trains, they're constantly connected to their phone, checking things and basically entertaining themselves. Rail travel in itself isn't particularly entertaining. And passengers are becoming more savvy. Basically, every single aspect of their life now is driven by communication, being connected, having just-in-time data, and being able to make decisions on demand. So from retail, all the way through to finance, all the way through to entertainment, people are used to being in control. And the railway and transportation in general is beginning to move in that direction. And we need bright, smart young people who are familiar with these technologies, who can get on board and drive these changes through. You look around my engineering office, it's an aging demographic. Engineering is quite bad in general for an aging demographic, white male demographic. Rail engineering is probably amongst the worst for that. It's full of people who are 45, 50 and above. They simply do not understand how this technology works. And they even view it as a bit of a waste of time, which is even more dangerous. So what could that look like? It could be the ability to treat a seat reservation as like a disposable item. It's dynamic, it follows you. You can reserve a seat on a train. If you want to get a different train later, cancel it, move it across. If you miss that train, the system automatically frees that seat up for somebody else to reserve it. You can begin to treat a seat reservation dynamically. How fantastic would that be? The technology's there, let's build it, we understand it. Smart ticketing, Oyster's been around for a while, but actually, how about doing ticketing differently? So more like an Uber, you pay per mile, or you pay per kilometre. You could have different peak rates for different times of day. Certainly the current ticketing system on rail is really confusing. I've been in the industry 3.5 years, it makes no sense to me, and presumably there's people in here who look at the ticketing and it confuses you as well. There's got to be a better way to do it, and we need people that have experience of using Uber and understand different ways of transacting for things, maybe a subscription service. There are new innovative ways to charge people for using a service beyond a confusing ticketing system. Railvolution 4, HS2. So this one needs probably no introduction. I dare say you've all heard of this. What is HS2? Well, actually, it is going to be revolutionary and probably needs no introduction. And the fantastic thing is, over the course of the various phases, every single person in this room, if they wanted to, could get involved in rail and join HS2. And there's almost a full career in building HS2 from start to finish. And what a legacy to leave behind for future generations than a brand new high-speed north to south rail link that makes the country smaller, brings people more closer together and drives the economic development of the UK. I mean, that is a hell of a legacy to leave. And actually, whilst they're building the track today for relatively low speeds, they're building it so that we can run much faster trains in the future. So it's a forward-thinking project designed for the future of the UK. In terms of capacity, it can move more people per hour than building 2 new motorways up and down the country. So it is phenomenal, the impact that it will make. And for certain cities or towns like Crewe, which will have a station, I think in the northwest everyone will appreciate Crewe has seen better times. Actually, in terms of regenerating parts of the country and enabling social movement for people, there is that benefit as well. I work in trains. It's easy for me to talk about trains all the time, but actually the infrastructure is just as important. So once you start moving to high speed and very high speed trains, ordinary track with ballast, which is the little rock things you see under the track, doesn't cut the mustard anymore. So actually you need to move to more of a slab track design where it's a solid concrete foundation below the track to deal with the vibrations and the speeds that you experience. And actually that slab track needs to sit on the right kind of ground. You need the right rock structures, you need the right soil types. So actually we need fantastic structural engineers and civil engineers to build these, not least the bridges and the tunnels. And we also need fantastic geotechnical engineers and geologists to help us plan these routes so that we're taking the route in the, down the most effective and cost-efficient path. Even in aerodynamics, the challenges to reach. So if you imagine we're going to be sending high-speed trains down tunnels, and actually there will be a lot of tunnels on the HS2 route to avoid nature reserves or to cut through tunnels, or quite large numbers of the UK is now quite heavily populated. If you send a train down a tunnel, you're going to build a pressure pulse ahead of the train. Now if that train's going fast enough, you run the risk of that pressure pulse when it reaches the end of the tunnel creating a sonic boom as it comes out the end. So if you can see what they've done in France, you can see the extension of the tunnel coming out there. See the slits in the top? That's basically a series of openings, a bit like on a silencer on a gun, that allows the sound wave to diffuse as it exits the tunnel entrance or tunnel exit. In Japan they do it differently. In Japan you'll have seen the CHAIN17 with like a weird duck bill shaped kind of feature on the front. They do it differently, so they deal with it with the shape of the nose of the train is another way to get around the problem. But again, challenges in all areas, and exciting engineering challenges to get involved in. Railvolution 5, new tube for London. So this is really exciting, and this is something I've been able to be directly involved in myself. So this is London Underground's vision for the future of tube travel on the deep tube lines. So these are the lines that have the little diddy trains, not the bigger ones. As I mentioned before, I'm relatively tall. I can only just stand up in these ones if I stand in the centre of the vehicle. And what they really want to do is create a train that, the design life of a train is 40 years. So if you think we're designing something today that has to remain relevant in 40 years' time, that's quite a challenge, particularly with the rate of change of technology in most industries. So what does this train look like? One of the things is London Underground's aspiration to start this train out with a driver, but at some point in its lifetime convert it to a fully driverless automated railway. So here you can see a view on where the driver's cab would be behind that black partition. And actually they want the design such that within 48 hours in a depot, we can convert it from having a driving cab to having additional passenger carrying space and having a fully automatic signalling system within 48 hours. So if you think about how that drives the design to enable maintenance personnel to affect that change, so it's cosmetic, it's functional, it's technical, within a 48-hour window, it completely changes the way that we go about designing a driver's cab. And we've been designing driver's cabs for a very long time. In terms of the passenger area itself, these are quite common on the bigger trains now, so through gangways. So the train becomes an entire tube. You can walk from one end completely to the other. But what that means is all the lost areas between the carriages that you used to have are now extra passenger carrying spaces, which boosts the capacity, which makes a big difference overall. These will be air conditioned for the first time. Now, that's the government saying these must be air conditioned because Londoners are going through pain right now because in the summer it gets really, really hot. From an engineer's perspective, that's quite challenging. So I'm cooling the interior of the train with an air conditioning unit, fine, I can do that. Okay, so I've now got this hot air that I've extracted. Well, where do I put that? Well, throw it in the tunnel. Okay, that's a closed system. Now I'm trying to pull air in from outside to cool the air. So you end up heating the tunnel outside. The passengers in the stations are stood essentially in the tunnel. So how am I, that heat has to go somewhere. So, but we've been told by the customer we have to cool the interior of the car. So that gives you, again, engineering challenges that you go, right, no one's really had to solve this problem in this way. How do we go about solving it? And we looked at all kinds of solutions to doing it, from the most kind of out there, which was actually having a tank of material on the underside of the train that has a phase change material in it. So it's got the right properties so that when you heat that material up, it changes phase, so it goes from liquid to gas or solid to liquid. So its temperature doesn't change, you're just using all the energy up in changing its phase. But then you'd have to remove that material and fit a new one at an appropriate time. Clearly, operationally, having to stop the train to swap that out was no good. And the end solution was we designed an air conditioning system that actually, it doesn't meet the standards, So, we're required to provide a certain amount of cooling per passenger. We couldn't do that much because we've got these Victorian tunnels and we can't put that much heat into the tunnel. So we've ended up with a slightly smaller, more compact system, coupled with cooling systems at the platforms to take heat away and up and out of the system entirely. But I thought it was a good example. And in terms of the aspirations from the customer, the aesthetics for the first time, the general fit and finish of this train is probably beyond what anybody's ever seen on a train before in terms of the materials, stainless steels, the upholstery they want to use. It's going to be a fantastic product for London when it's done. Railvolution 6, and this might be pushing the boundary a little bit, but Hyperloop. Who's heard of Hyperloop? Most people. It's pretty cool. The concept came from Elon Musk originally, so I think he made his money in PayPal, now runs Tesla Motors. He had this idea for Hyperloop. He's quite busy. I think he's quite busy trying to change the automotive sector with the Model 3 at Tesla, so thought, I've not really got time to change the railway as well. I'll let someone else work that one out. So he's made his ideas open source, and there's actually 2 companies in the States looking at Hyperloop today. For those of you that don't know what it is, it's essentially taking a big long tube. You kind of reduce it to a very, very low pressure. You stick a pod inside it. You fit the pod with people. You catapult the pod with some electron magnets, and it zooms down the tube at about 760 mph. And of course, that's possible because the drag and the air resistance and the friction are reduced to a minimum. Is this the future of the railway? Well, it's it bears the closest resemblance to this is a train. It's infrastructure and the vehicle itself working in harmony, designed together as a complete system to work together. There is essentially a track, there is essentially a train. Will this one day be viable? I don't know. Will it be viable in 10 years, 30 years, 50 years, or never? We don't know. But actually, there are people working on it today. Clearly the benefits are there in terms of the speeds it can theoretically generate, and actually, for people getting involved in rail today, maybe that is the future of the railway. And I think, again, for people looking for careers that are different and industries that are growing, and rail worldwide is growing, rail is linked to population growth. I think we'll all agree that population growth isn't going away anytime soon. We need to move people around very densely packed areas in an efficient and effective way, and rail is a very, very good way to do that. But, I can sit here and talk about the flagship projects that are pushing the boundaries, but as we all know, engineering is just as much about evolution as revolution. This is the new Crossrail station at Canary Wharf. I think you'll agree. It's a fantastic piece of civil engineering, it's a fantastic piece of architecture, and the people that were involved on that in rail will be very, very proud and pleased with that work they've done. These are the current generation tube trains. I've shown you the next generation. We've just finished delivering the one on the left to 4 of the larger lines in London, and the Victoria line as well a few years before that. These are fantastic products. Passengers love them. The ones on the left are the first large trains to be air conditioned. They're both significantly faster. They use modern traction systems. You've got much faster accelerations and decelerations. They're lighter. They've got a more well thought out internal environment. Ergonomics has come a long way. What you could get away with, I say a train's 40 years old, what you could get away with 40 years ago in terms of comfort and ergonomics is completely blown out of the water by what we expect today. So, again, teams of electrical and mechanical engineers and industrial designers put a lot of work into building these, and already these are iconic pieces of design that sit within the London cityscape that people enjoy to use and do use every single day. Every single project that we do, there's engineering structures. So if you're just interested in theory and analytics and building efficient, lightweight, effective structures from aluminium, if you're a mechanical designer, or steel or concrete if you're a structural designer, this is, there's plenty of those opportunities as well. And in terms of signalling, so in terms of control and functional architecture, we need to move these people around the country, as I've said, much more effectively, much more efficiently, higher capacity, higher speeds, but most importantly, safely. And this came up in the Royal Aeronautical Society's talk. People are relying on you to get them from A to B. Yes, they'll bitch and moan if it's late, and yes, they'll bitch and moan if it's too slow, and they'll bitch and moan if the Wi-Fi doesn't work. But fundamentally, the overriding priority and concern is getting them there in one piece. And everything else, of course, is a nice to have. And that's, but of course, the whole system we try and improve. And whether you're actually, again, you're not on the bleeding edge of design, but you're just maintaining and upgrading and improving our existing infrastructure from tracks to signalling to overhead catenary to tunnels, it all helps to move people around the country. It forms an artery part of the UK's transport network that allows people to live their lives, get from A to B, visit their parents, friends, get to school, get to work, get home again. People, if you design something properly, people will barely notice it's there, but that's what makes it obvious that you've designed it properly. People take it for granted and they use it, and that means it's doing its job. So to wrap up then, so why is now a great time to get involved in the railway? Hopefully I've given you an idea as to some of the projects you can get involved in. Hopefully kind of it opens your eyes to what we do every day. Why do we need you? And what are the benefits to you guys for considering a career in rail? It's a growing industry. It continues to grow. And actually there's £100 billion worth of investment in the railway in just the next 10 years. And looking beyond that, there's even projects in the pipeline like HS2, the later phases, HS3, which will be a massive benefit to Manchester and the North, including Crossrail 2 as well. And in order to deliver that work, that £100 billion worth of work in the next 10 years, 100,000 more people are needed in the industry in order to deliver it. There is currently not enough people to deliver that work. And of those 100,000 people, about 40% of those need to be engineers and people in technical roles in order to deliver. You know, the railway is a very technical, engineering reliant industry by its very definition, by its very design. And we need great, talented, clever, innovative people, not just to deliver what we've committed to, but actually to deliver more and improve and innovate and push the boundaries of what rail travel is, whether that's Hyperloop, whether that's HS2, or whether that's something in between. So I would urge you to consider joining the Railvolution. I'd like to thank you for your time. We've also got the exhibition stand outside if you have any questions. I've got a video to end, and I don't know if you've got time for Q&A, but there's a video to end, and then that's it.
I always wanted a job that would allow me to travel. But now I'm transforming the way that everyone travels. And making UK rail faster than ever.
I always wanted the best toy in the box. This one's 1,000 tons and lays a kilometre of track a night. It's awesome.
I want to show the world that Britain can still lead the way in technology. My data systems make travel smarter and safer.
My friends always used to say I was a control freak. But when you've got 40 trains on your network at rush hour, control is everything. I want to create components built to transform 21st century travel. My research gives the industry cutting-edge products and gives me the job I love.
I want to be part of the team making the big decisions. Sometimes a whole infrastructure project can depend on the solutions I provide.
I want to look back on my career and think, I really did something. And every time I look at the scale of this project, I think I have.
It's about being part of an incredible team with so many talented people dedicated to the same goal. It's about walking through an awe-inspiring workplace and knowing this is my office. It's everything I ever wanted.
Right, so thank you very much, everybody.